Hello everybody, welcome into another lesson. So today we are going to talk about graphing the square root function. And then we're going to discuss some very interesting things also about symmetry with inverse functions. So here you have f of x equals the square root of x, and well, we would like to graph that. Considering the square root, what is the domain? In other words, what values of x is this function defined for? 0 or greater, right? It's not defined in the real numbers for any negative numbers, so we can only take x from greater than or equal to 0. So x, when x is 0, will give you a y value of 0. We'll plot that. What about when you have 1 for x? Well, the square root of 1 is 1. Then how about when x is 4? Square root of 4 is 2, which would put you over here. And then 9 would be 3. So we have a pretty good representation there. So here's roughly what the curve for f of x equals x squared looks like. F of x equals the square root of x looks like. Now, let's say right beside it I want to draw its inverse. What's the inverse function? The inverse of the square root of x, of course, is known to be x squared, particularly since it's just a positive square root of x. It's going to be from where x is greater than or equal to 0. So what that means is then its inverse, f of x equals x squared, just the piece from where x is greater than or equal to 0 will be the right side of the parabola. So if you put in 0 for x squared, you'll get 0. Put in 1 for x squared, you also get 1. If you put in 2 for x squared, you end up getting 4. Put in 3, you get all the way up to 9. So here's the right side of the parabola right here for f of x equals x squared. So here's f of x equals square root of x. Here's f inverse of x equals x squared. Now, I'm going to draw the line y equals x. So 0, 0, you got 1, 1, 2, 2, 3, 3, 4, 4, yada yada. Right? Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, yada yada. So, in general, it's true then that a function and its inverse have symmetry about the line f of x equals x, or y equals x. So a function and its inverse are always symmetric about the line y equals x, or f of x equals x. So that's an interesting tidbit to know about graphing a function and its inverse. I got plenty more here. We're going to talk about reflections next. So let's say this time I decide I'm going to graph f of x equals negative of the square root of x. So I'm going to do f of x equals negative of the square root of x. Okay, so what's that domain which x is defined for? It's still greater than or equal to 0, right? So at 0, you would get 0. But if you take 1, negative of the square root of 1 is negative 1. So you get the point 1, negative 1. And then if you take x is 4, negative of the square root of 4 is negative 2. So you would end up getting 4, negative 2. And then, of course, we put in 9. Take negative of the square root of 9, you'd end up getting negative 3. So this is what the curve for negative f of x equals negative square root of x looks like. So notice it takes the original and it reflects it in the x-axis. It uses it as a mirror. In fact, it's true for any even power root. If you have the negative sign outside of the root operator, if it's outside of the root operator, it reflects it in the x-axis. So that's something to note, and we're also going to talk about the other way. The other way would be, let's take the positive square root this time of negative x. So let's take the f of x equals the square root of negative x. This will yield another type of reflection. Now, interesting thing here also, what would the domain of x be in this case? Well, you have a negative inside of the square root. If you go with positive x values, you're going to get square roots of negative numbers, which are not defined in the set of real numbers, right? That means the domain is actually less than or equal to 0, right? Because if you take a negative of a negative, you'll get a positive for which the square root function's defined for. So if we put in x is 0, you'll end up getting 0 still. Now, if I put in negative 1 for x, I'll get negative negative 1, which would give me the square root of 1, which would be 1. So I'd end up at negative 1, 1. If I put in negative 4, I would end up getting the square root of positive 4, which is 2. Then if I put in negative 9, I'd end up getting the square root of positive 9, which would be 3, which would go right here. And then I can draw that curve through here. And that is roughly what the square root of negative x looks like. F of x equals negative of the square root of x. So if the negative sign is inside of the square root operator, it uses the y-axis as a mirror and reflects it in the y-axis. All right. And one last one. Let's take f of x equals negative of the square root of negative x. So we're going to have two reflections. F of x will equal negative of the square root of negative x. So we have a sign outside of the square root operator, which means it's going to reflect in the x-axis, use that as a mirror, and you have one inside of the square root operator, which would actually also reflect in the y-axis. So you have a double reflection. So what would the domain of x be? It would have to be less than or equal to 0 again, because if you use positive values of x, you'll end up getting the square root of a negative number, which is undefined in the reals. So if you put in 0, well, you still get 0, right? Now let's say I put in negative 1 for x, I'll end up with a square root of positive 1, and if I negate that, I'll end up getting negative 1. So I'll get the point negative 1, negative 1. Now if I put in negative 4 inside for the x, I'll end up getting the square root of 4, and if I negate that, I'll end up getting negative 2. And then last but not least, let's put in negative 9, which would give me the square root of 9. Negate that, I'll get negative 3. So here is the curve for f of x equals negative of the square root of negative x. I've done a double reflection. It's reflected it in both the x and the y-axis from the original square root of x. So those are your reflections. Now, let's say I have something like f of x equals negative 5. Now let's not do that because I don't want to run out of space on the graph. F of x equals negative 2 times the square root of x. So now I have a coefficient on that square root of x function. Alright, so what's going to happen? If you have a coefficient outside of the square root function, that denotes a vertical stretch. It's going to stretch it vertically, and on top of that, you have a negative, which means it's actually going to reflect it in the x-axis, since the negative's outside the square root. So you have a vertical stretch. Since that coefficient is greater than 1, it's a vertical stretch. If it were less than 1 but greater than 0, then you would have a vertical shrink, which we'll get to next. But the domain of x in this case, since it's just the square root of positive x, would be greater than or equal to 0. So when x is 0, you would still get 0, right? Alright, now let's put in 1 for x. Square root of 1, of course, is 1 times negative 2 is negative 2, which would go right there. Now let's put in 4. Well, square root of 4 is 2, right? 4 times negative 2 is going to be negative 4, which will go right there. All right, then how about when x is 9? Whoops, I said 4 is negative 2. Dang it. No, 4 is negative 4. Gosh, I can't even count today. Here it is. All right. Then what about when x is 9? Well, the square root of 9 is 3 times negative 2 is negative 6. So let's graph this bad boy. And then you have what's called, that's definitely vertically stretched from the original square root of x, and it's reflected in the x-axis from the original. So that's what that negative sign does, and that coefficient of 2 stretches it vertically. All right. Let's say f of x equals 1/3 times the square root of x. So f of x equals 1/3 times the square root of x. Well, the coefficient is greater than 0 but less than 1, so this is going to be a vertical shrink. And it's a vertical shrink since the coefficient is outside of the square root operator. So let's, of course, put in 0 for x. You still get 0. But what about when x is 1? Well, the square root of 1, of course, is 1 times 1/3 would put you about right there. How about the square root of 4? Well, that's 2 times 1/3 would put you at 2/3, right about there. Then what's the square root of 9? When x is 9, well, that's 3 times 1/3 will put you at 1. So there's roughly about what the graph of f of x equals 1/3 times the square root of x does. It vertically shrinks it. It's not quite as tall as the normal square root of x. So if in any function, and specifically this one too, if the coefficient is outside of the square root operator, it's messing with a vertical. Now we'll get to when you have it inside the square root operator in a little bit here. All right, this one's a little bit different. So you have the square root of x plus 1/4. All right, so you have the square root of x plus 1/4. Well, for any function at all, and it's true in this case, if you have the polynomial, or if you have your function of x, then outside of that you have plus or minus a number, that indicates a vertical shift. That means I'm going to take the coordinates, my y coordinates, and move it up 1/4 of a unit. So I'm shifting upwards 1/4 of a unit. So, for example, if I put in 0 for x, what do I get? Square root of 0 is 0, then plus 1/4. That would actually put me at 0 1/4, which would be right about there. I would start right there. Now, if I put in 1, square root of 1 is 1 plus 1/4. That put me at 1 1/4, which would put me about right there. Then if I take the square root of 4, well, that's 2 plus 1/4 would put me at 2 1/4, which would put me about right there. And then if I take 9 for x, which would be square root of 9 is 3, well, I would get about 3 1/4. So I've started a fourth of the way upward. I've shifted upward a fourth of a unit. So if you have plus or minus outside of your square root operator, that means you're shifting up or down that many units. I've shifted upward 1/4 of a unit in this case. All right, what's next? This time we have f of x equals the square root of x minus 2. So f of x equals the square root of x minus 2. Since the minus is outside of that square root operator, this means I'm shifting downwards 2 units. Okay, so let's say I take 0 for my x, right? Square root of 0 is 0, then subtract 2, I would actually be at the point 0, -2, which will put me right there. Now, what if I put in x is 1? If I put in 1, get the square root of 1, which is 1 minus 2, I get -1. So I get 1 -1. All right, let's put in 4 for x. Well, that would give you square root of 4, which is 2 minus 2 is 0. So actually my x-intercept would be at 4, 0. And then for good measure, why don't we put in 9 for x? Well, square root of 9 is 3 minus 2 is 1. So I'll get the 0.91. So I've taken everything and shifted it downward 2 units. So that's what you would get when you shift it downward. All right. Now here's a different one. F of x equals the square root of x plus 6. All right, so f of x equals the square root of x plus 6. So this is about to get very interesting. Now, this time the plus is inside of the square root. So what is that going to do? Well, let's look at your domain, right? Any number inside of the square root has to be greater than or equal to 0, right? So take what's inside of the square root, that x plus 6, set it greater than or equal to 0. Then solve for x. That tells you that your domain has to be x is greater than or equal to -6. Because if you go with -7 or less, you'll end up with the square root of a negative number. But if you put in -6 or greater, you'll end up with 0 or greater, which it's defined for. Now, set also that x plus 6 this time equal to 0. Which of course would give you x equals -6. That's going to be the point for x that you start at. So you're going to actually start at -6, 0. So on the inside, if you have it on the inside, what that means is if it's x plus 6, you're actually going to shift the square root function 6 units to the left. If it were x minus 6 inside the square root, you would set x minus 6 equal to 0, and then you would have x equal to +6, which would mean you're shifting it 6 units to the right. But in this case, you're shifting it 6 units to the left. So here is -6. Well, -6 plus 6 is 0, right? Square root of 0 is 0. Now what if I put in -5 for x? Well, -5 plus 6 is 1, square root of 1 is 1, so I'll end up getting -5, 1. Now if I put in -2 for x, that would give me, of course, square root of 4, which would be 2. And then, let's see, if I put in 3 for x, that would give me 3 plus 6, the square root of 9, which is 3. So I'd be at 3, 3. So let's draw this square root function. So yes, I've shifted everything to the left 6 units. And the y-intercept, of course, would be the square root of 6. It'd be 0 square root of 6. So you could see it crosses the y-axis there too. But yeah, so this denotes what's called a horizontal shift. You're shifting to the left 6 units. It's a horizontal shift as opposed to a vertical shift. All right. Good one. We have... No, I don't want to do that. How about the square root of x minus 1? So let's say I have the square root of x minus 1. This time you have the minus inside of the square root. That denotes another horizontal shift. That is a horizontal shift. So set that x minus 1 equal to 0, which means that x would equal 1. So you're going to start at the point where x is 1. Now, so it shifts horizontally to the right 1 unit. Now, what is the domain for x for which all values are defined? Again, inside the square root has to be greater than or equal to 0, right? So set x minus 1 greater than or equal to 0. You get that your domain has to be x is greater than or equal to 1. So x is greater than or equal to 1 is your domain. So when x is 1, 1 minus 1 is 0, square root of 0 is 0. So you'll end up starting at the point 1, 0. Now if you put in x is 2, 2 minus 1 is 1, square root of 1 is 1. So you'll end up at 2, 1. Let's put in x is 5. 5 minus 1 is 4, square root of 4 is 2. So you'll be right there, 5, 2. Then put in x being 10. 10 minus 1 is 9. Square root of 9 is 3. So you'd be at the point 10, 3 right there. And then graph this, and then you can see everything has shifted to the right 1 unit. So if you have plus or minus inside of the square root, that means you're going to do a horizontal shift, either left or right. Okay. Got 3 more. Now what if I did this? Square root of x minus 1 plus 7. So inside of the square root, I have f of x equals the square root of x minus 1, that whole quantity, plus 7. So this time I have both a horizontal and vertical shift. I'm shifting the starting point to the right 1 unit, right? Set x minus 1 equal to 0, x would equal 1. And then I'm also going to shift it upward 7 units. So it's shifting to the right 1 and upward 7 units. Now, what is the domain for this square root function for x? Set x minus 1 greater than or equal to 0, x has to be greater than or equal to 1, right? So it would start with x being 1. All right. So let's put in 1 for x. 1 minus 1 is 0, right? Square root of 0 is 0, but you have that plus 7. So it's going to shift all the way up 7 units. There's your starting point. Now what if I put in 2 for x? Well, 2 minus 1 is 1, right? Square root of 1 is 1, then plus 7 is 8. So you'd be at the point 2, 8. And then if I put in 4 for x, no, I'm sorry, 5 for x. Let's put in 5. 5 minus 1 is 4, plus Oh yeah, 4. So square root of 4 is 2 plus 7 is 9. So you would be at the 0.59. And then if I put in 10, if I have 10 for x, well, they give me 10 minus 1, which is 9. Square root of 9 is 3, plus 7 is 10. So I'd be all the way up to 10, 10, right there. So it's going to start at the 0.17. Oh, that was a terrible curve. Hold on a second. Let me amend this a minute. I did terrible there. Let me draw it better. It's better-ish. So there's my square root function. And notice I won't get any y values less than 7. It just doesn't happen. All my y values are greater than or equal to 7. Alright, I have like 2 more. Good one. 2 times the square root of x plus 5, that quantity, minus 1. Alright, so f of x equals 2 times the square root of x plus 5, that whole quantity, minus 1. So I have like 3 things going on here. That coefficient of 2 on the square root means I'm going to vertically stretch it by 2 units. So I'm vertically stretching this. Now, I have x plus 5 inside of the square root, which means I'm going to shift the square root to the left 5 units. If you set x plus 5 equal to 0, that gives me the fact then that x would start at negative 5, which would be all the way over here. And then that minus 1 outside of the square root means I'm going to shift everything downward 1 unit. Now if you take x plus 5, set it greater than or equal to 0, that means x has to be greater than or equal to negative 5 for your domain. So the domain for x is greater than or equal to negative 5. So let's put in negative 5 for x. Well, negative 5 plus 5 is 0. Square root of 0 is 0. Times 2 is 0. Minus 1 is negative 1. So 1, 2, 3, 4, 5. I'll be at 5, negative 1. Negative 5, negative 1, excuse me. I start at negative 5, negative 1. Let's put in negative 4 for x. So negative 4 plus 5 is 1. Square root of 1 is 1. Times 2 is 2. Minus 1 is positive 1. So I'd actually be at negative 4, positive 1. And then let's go all the way to x is negative 1. Well, negative 1 plus 5 is 4, right? Square root of 4 is 2. 2 times 2 is 4. Minus 1 is 3. So at negative 1, you'll end up getting a y value of 3. And then, for good measure, let's do one more. Let's say we do x is positive 4. So 4 plus 5 is 9. Square root of 9 is 3. Times 2 is 6. Minus 1 is 5. So you'll end up getting the 0.45. So that would put you right there. So now we can graph this bad boy. Which, yeah, we have definitely vertically stretched this square root function. We've shifted the starting point to the left 5 units and downward 1 unit. So you have pretty much everything going on. The only thing is you don't have a reflection. But let's talk about, let's do a couple more here. Let's say this time I do the square root of 2x. So I have the square root of 2x. So this time I have a coefficient inside of the square root. A little bit different. This is a little bit different. So if I set 2x greater than or equal to 0, That would mean x still is greater than or equal to 0, right? Okay, well, and my starting point would still be at 0, 0, because there's no shift of any sort. I've just stretched it by a factor of square root of 2. So if I put in 0, what do I get? I get 0. Alright, what about when x is 2? If x is 2, that means then that I get the square root of 4, which is 2. So I would have the point 2, 2. Alright, what about when, let's see, what about when x is 8? If I put in 8 for x, what do I get? I get the square root of 16, which is 4, which would put me over here. So let's graph this, and there's roughly what the square root of 2x would look like. Well, notice it still is a vertical stretch because the coefficient, you might remember, you can separate these into two separate square roots. You could take the square root of 2 times the square root of x, while the square root of 2 is greater than 1. So this is a vertical stretch, but it's also a horizontal shrink because it's not as horizontal. It stands up more. It's not as horizontal. So if you have a coefficient of any sort inside of the square root, that denotes that it's messing with the horizontal this time. And if the coefficient inside of the square root is greater than 1, it's a horizontal shrink. And a horizontal shrink is a vertical stretch at the same time. So it's the opposite of each other. A horizontal shrink is a vertical stretch, and then a horizontal stretch is a vertical shrink, as we're about to see here. Because let's say I take the square root of 1/2 x. So this time I have the square root of 1/2 x. My coefficient is inside of the square root. Now, since my coefficient is greater than 0 but less than 1, this will be a horizontal stretch, which would mean a vertical shrink. And the domain would still be x is greater than or equal to 0. If you put in 0, what are you going to get? You'll end up getting 0. Alright, so now, let's say I put in 2. Let's say I put in 2. So 1/2 of 2 is 1. Square root of 1 is what? That's 1. So I would end up getting the point 21. Now, let's say I put in, let's see, 5, 6. Yeah, let's say I put in x is 8. So what's half of 8? That's 4. Well, the square root of 4 is 2, so I'll be all the way over to 8, too. So here's what the square root of 1/2 x would roughly look like. Notice it's more horizontal than normal. It almost lays flatter down. That's a horizontal stretch, and it's not as tall vertically, so that's a vertical shrink. So if you have a coefficient inside of the square root, and it's greater than 0 but less than 1, that denotes a horizontal stretch, which is a vertical shrink at the same time. So that's it for graphing the square root function. Next lesson we'll graph the cube root function. And I can tell you that graphing this, if you were to try to graph the 4th root or the 6th root, any even power root, it's relatively similar to graphing the square root. Just kind of like when we were graphing quadratic equations and 4th degree and 6th degree, they're all kind of similar. Even power polynomials to even powers, when you have even power roots, they also graph relatively similar to each other. Next lesson, we'll graph the cube root function, which we'll also see that odd power roots tend to graph relatively similar. So I hope everyone has a great night. Take care.